Hello, everyone, and welcome back to another edition of this data analysis training. My name is Stanley, the founder of Analytics, and in today's video, I'll be walking us through an independent sample state test, as well as how to perform it and how to interpret the outputs in SPSS. Now, what is an independent sample state test? An independent sample state test is a statistical method used to determine whether there is a significant difference between the means of two unrelated independent groups of the same continuous dependence variable in the population. Now, what do I mean by that? Independent sample state test is basically a method to try to test the most effective between two groups on an entity, on a continuous entity. So for example, let's say we have two particular drugs and we want to test the most effective drug in treating malaria, for example. So we have drug A and drug B and we want to check which one is the most effective. So instead of trying to use another method, we can just actually take the average. We can create a continuous dependence variable, trying to scale on a scale of 1 to 10, try to record the level of recovery of our patients. So we will now group those patients into two: patients that took drug A and patients that took drug B. They will now take the mean of the scale of the recovery rates of those patients that took the first drug, take the average, then take the mean of the patient that took the second drug, take the average, then extract a sample. Let's say, for example, we have thousands of patients that took the two drugs. Due to cost expenses and some other factors, we are unable to try to account for each and every particular person that took the drug. So instead, we use a method called an inferential statistics, which is basically a way to use a sample to conclude for the whole population. So what do we do instead? Instead of trying to calculate the mean of the whole thousands plus of patients, we just extract probably 10 to 20 people out of the whole 1,000 responses. What do I mean by that? I mean 20 people that took drug A and 20 people that took drug B, because the group must actually be equal. So they must be equally grouped. There's no it should not be 30-10 or 35-5. It should be 20-20, 50-50%. So after they've grouped them, they will now take the average and try to try to look at the difference between the two means. They will now take a t-test. You will now take a t-test. And when you now take the t-test, you will now take the significance of the t-test to check if there's actually a significant difference in the population, whereby you will now accept the null hypothesis, or if there is no change in the population. So if there is no significant change in the population, in that case you accept the null hypothesis. That means that both of the drugs are ineffective overall, or both of the drugs actually have the same performance rate on the disease they're trying to cure. So moving on, in this our example, we are going to be using exam score between male and female to see whether male actually performing better than females in the population. But before moving on to that, we have to also check the assumptions of an independent sample state test. Then moving on, so there are three basic assumptions of independent sample state test. It must be the difference between two means, that is sample A and sample B, like I said. Then we now choose to either accept or reject the null hypothesis, and I said notes before, inferential statistics. So it's basically an inferential statistics, like I've said before, and it must be equally grouped. So the second assumption is that the dependence variable must be continuous. It must not be a categorical dependence variable. It must not be qualitative, but it must be a continuous variable. Then moving on, we'll move on to the actual move on to the actual SPSS to see what I'm actually talking about. So this is our independence variable, which is the sex. So it's basically our factor, and this is our dependence variable, exercise 1. So basically the scope of this data set is that the students actually performed 3 exercises: exercise 1, exercise 2, and exercise 3, right? And we are trying to check for this exercise 1, which categories are actually performing better. Is it the male category or is it the female category? Then after we've done that, we'll now specify our hypothesis. The male and female perform equally in the population. That means there's no significant difference between the male and female, allowing us to conclude that no one is performing better than another, and like no one is performing better than the other. Then the alternative hypothesis is that the male is performing better than the female. So moving on, and when we want to conduct an analysis after data cleaning, the first thing we want to check is the exploratory data analysis. So that's where we use the explore, like we've done in the previous video talking about the descriptive statistics in SPSS. So I chose explore because I want to like get more information apart from the descriptive statistics, which is talking about the average exercise 1 performance. And also I also want to like try to group the exercise 1 performance across the male and female, because that's what's actually checking. So I clicked on explore, drag the exam version 1 in the dependence list, then our factor variable, which is sex, then move on to plots. I have to check for the normality, because another assumption of an independent sample test is that if your data set is less than 30, you must account for normal distribution. Your data must be normally distributed. So click on histogram and check for the normality plots with test. Then I clicked on OK. Then the statistics, I want the descriptive statistics as well. Then I clicked on OK. So this is the output. So we can see that the average value of male, we have 8 male who took this test, and we have 11 females who took the test. There are no missing values. The average score for male is 20.75, while the average score for female is 22.91. Then moving on, this test of normality, you can see that our p-value is greater than 0.05, allowing us to conclude that our dependent variable is normally distributed. You can also check it from this histogram by trying to create a normality plot with stairs, like trying to map out the curve of our distribution. Then we can do the same for the female as well. And we can also see in the box plot that there are no outliers present. That means the spread of the distribution actually like evenly distributed across the whole population. So there are no extreme values or unusual value, else it will be denoted by a dot, allowing us to conclude that okay, there are some outliers present in our data set, and which might cause us to remove the data set from the sample, or else our analysis will not be accurate, as those outliers will be influencing our analysis. So moving on, we are going to be doing the actual independent sample state test, and to do that we go to analyze, compare means, because that's what we are doing basically, then independent sample state test. Right, your test variable is exam version 1, grouping variable is on sex, then I want the time phase complex interval, then define variables. So the initial variable is coded as 0. That means male is coded as 0 and female is coded as 1. Yeah, male is coded as 0, female is coded as 1. As I've done here, that's what I did at 0 and 1. So you can decide to code male as 1 and female as 2 depending on what you actually want. Then click on OK. So another thing, another assumption of an independent sample state test is homogeneity of variance or equality of variance. And one way we can actually test for it is to check for this p-value. If this p-value is less than 0.05, we will reject the null hypothesis, saying that equality of variance is not assumed. But if it is greater than 0.05, we accept the null hypothesis, which is actually what we need, saying that equality of variance is assumed. So since that has been concluded, we will now move to interpreting our t-test and saying that the mean difference is actually minus 2.159. And the reason why it is actually so is because if we check here, you can see that female has a higher mean than the male. And according to the scope of the data set, higher mean indicates a better performance. So as the mean is actually negative, which is actually not significant, so since it's not significant, you will say that this result, this a negative difference, which is indicating that females perform better than the male in the sample, it is actually not significant in the population, which basically means that we cannot conclude the same thing in the population, and this difference that actually occurred in the sample is actually by chance. So this difference is actually not real, as it is not significant in the population because our p-value here is greater than 0.05. So, and if peradventure our p-value here is less than 0.05, assuming that our equal variance is not assumed, we'll move on to interpret this particular value, this particular t-test, which they actually both arrived at the same conclusion, allowing us to conclude that our p-value is actually not, as our p-value is actually not significant, indicating that equal variance is not, indicating that the difference is actually not significant, which states that both the male and the female actually performed equally in the population. So thank you very much for watching and have a nice day.